In this video, we're going to talk about how to plot parametric curves themselves. And what I want us to recognize from this, right from the get-go, is parametric curves, they live on the xy plane. So whenever we're plotting a parametric curve, we're plotting it on the xy plane. And for this example, let's consider the following parametric curve. The curve that we're going to look at is the curve of x of t and y of t, where x is equal to t squared minus 3 and y is equal to 2t plus 1. So from this notation, and excuse me, the last thing actually I need to tell you is, well, the value of t's, we're going to consider t values from minus 2 all the way to 3. And just so we're on the same page here, what this notation above means is we actually just get to consider x of t is equal to t squared minus 3 and y of t is equal to 2t plus 1. And the way in which we're going to try plotting here is by making a table. So this should feel very reminiscent to how we first started to plot functions when we're first starting to learn what lines, what parabolas, and what some other functions, y as a function of x, look like. So if we're trying to make a table here, we're going to make a table that has a column of t values. Then we're going to make a column of x values, followed by a column of y values as well. And then the actual point that we are going to plot on the xy plane. So the t values we're going to choose here are between minus 2 and 3. So let's just go in integer steps. Minus 2, minus 1, 0, 1, 2, and 3. And then to figure out what the respective x and y coordinates are that we're going to ultimately plot on the xy plane as the point x comma y, we just need to substitute those t values into those formulas. So for example, when t is equal to minus 2, we plug that minus 2 into the x equation, which is minus 2 squared minus 3. And in this case, well, this equals 1. So when plugging into our x and y equation, our x is equal to 1. Let's figure out what y is equal to when t equals 2. For the y equation, when t equals 2, or minus 2, excuse me, we have to take minus 2, multiply it by 2, and add 1. That's just y of t when t equals minus 2. And this gives us a value of minus 3. So the first point in which we would plot is the point 1 minus 3. And we're just going to do something similar for all of these points. Into the x equation, just put in t equals minus 1, square it, subtract 3. And that'll give us a minus 2. So the next point's x value is minus 2. The next y value, if we do that, it's 2 times minus 1 plus 1. And that'll give us a minus 1. So the next point that we could plot will be minus 2 minus 1. And we could keep doing this for all these values. When t is equal to 0, plugging 0 into our x equation, that's going to give us a minus 3. When t is 0 and we plug it into our y equation, that's going to give us a plus 1. When t is equal to 1, plugging that into our x equation, that's going to give us a minus 2. And when t is equal to 1, plugging that into our y equation, that will give us a 3. When t is 2, plugging that into our x equation, that's going to give us our 1, or a 1. When t is 2, plugging that into our y equation, that is going to give us a 5. And finally, when t is equal to 3, plugging that into our x equation, that is going to give us a 6. And when t is 3, plugging that into our y equation, that's going to give us a 7. So the last point that we'll plot is 6, 7. So we have a list of points now, and we can go over to the xy plane to actually plot those. So let's do that next. Again, that's our x. That's our y. That's minus x. And minus y. So the first point, if we remember, the first point we had was 1 minus 3. So when x equals 1, we can go over, and when x is 1, or when t is equal to negative 2, our y then is minus 3. So we're over here. So this is our point, 1 minus 3. And that corresponds to when t was minus 2. Our next point was at minus 2, minus 1. So at minus 2, minus 1, x is minus 2. We're at minus 1, so we're down there. And that was when t is minus 1. I'm just plotting these t values along with the points. In general, we don't need to plot these values. I just want to make sure we're on the same page for this plotting exercise. All right, so the next point, when t is equal to 0, we want to plot minus 3, 1. So again, we go over minus 3 steps. What was the point? Minus 3, 1, and we go up 1 when t is equal to 0. So this is minus 3, 1, and that happened when t was 0. The next point, minus 2, 3, and that happens when t is 1. So x equals minus 2, go over 2 spots, and then go up 3 spots for that 3. And that's when t is equal to 1. All right, finally, we're getting down there. The next point after that is when x equals 1, y equals 5, when t is equal to 2. So move over to x equals 1, and then y equals 5, go up 5 spots. And that's the point 1, 5 when t equals 2. And the last point that we tried to plot was this point when t equals 3 at x equals 6, y equals 7. So we'll move over 6 spots, go up 7, and that's going to be the location of our last point. So that's at 6, 7, and that happens when t is equal to 3. So if we're trying to connect this curve, we can connect these points in successive t values or ascending t values of our parameter. So when t equals minus 2 to t equals minus 1, to t equals 0 to t equals 1, to t equals 2 to t equals 3. And along with that curve, because of the ordering of that parameter t, we also know that curve has a direction as well. So this curve looks like it's going around what appears to be clockwise. So in general, we can plot parametric curves much in the same way that we've plotted functions in the past, except both the x and y coordinate are both functions of our external parameter, in this case, a parameter t. And the last thing that I will say is I want to emphasize that parametric curves live on the xy plane. In the previous videos, we decomposed our parametric curves that live on the xy plane into functions, x as a function of the parameter t alone, and y as a function of the parameter t alone. These two individually are functions of that parameter, but we need to plot both of those coordinate functions, x of t and y of t, on the xy plane for it to be a parametric curve.